This is Juno 6, Paper 1, Question 2b. Kevin climbs up a rope, as shown in the diagram below. He takes 6 seconds to climb a vertical distance of 3 metres. Kevin weighs 400 newtons. Calculate the work done by Kevin when he climbed the rope. You're advised to show clearly how you get your answer. So, work done is force by distance, and the force that he's moving there is his weight, and you're already told his weight is 400 newtons, and the distance he's moving is 3 metres, and that's going to give you 1200 joules. And so there's a mark there for your answer, 2 marks for your working out, and 1 mark for your equation. Calculate the average power generated by Kevin. So your equation is power is work done over time. The work done is 1200, and you're told to weigh up in the first part of the question. He takes 6 seconds to climb the rope. So you're going to divide that by 6. And that gives you an answer of 200. Now, if you did make a mistake calculating your work up here, you can get an error carried forward and get 3 complete marks for this if you show you're working out and you show that you put in this number from up above. So there's a mark there and a mark for your equation. Part C, a ski lifter carries a skier of mass 6 kilograms from the 60 kilograms from the bottom to the top of a ski slope 250 metres higher. Now it's quite significant they've given you that vertical distance there. How much potential energy has the skier gained when she reaches the top of the slope? So just use your potential energy equation, mgh, and she's got a mass of 60, acceleration due to gravity is always 10, and the vertical height that she's moved through is 250, and that gives you 150,000 joules. And the unit's already there, so there's going to be no unit mark. So you get 1 mark for this, you get 1 mark for your working out, and 1 mark for recognising that G was 10, and 1 mark for GP equals MGH. So just move that a little bit so you can see the answer. So GP equals MGH, 60 by 10 by 250, gives you 150,000. The skier then slides down the slope starting from rest at the top. Using the principle of conservation of energy, calculate the skier's maximum possible speed when she reaches the bottom. Now, she had 150,000 joules of gravitational potential energy at the top, and that's going to be equal to her kinetic energy at the bottom. And so we can write 150,000 equals a half times, I'll just write half mv squared in there so we have more room. So that's equal to half times her mass, which is 60, times v squared, which we are looking for. Now you need to be careful just with the half, but it's probably wisest just to do half of 60. So that's equal to 30 times v squared. And so to get v, you're going to have to divide 150,000 by 30 and take the square root of your answer. And that comes out to be 70.67 or 70.7 metres per second. So there's 1 mark for your answer. There is 2 marks for your working out here, and 1 mark for your equation up here. When her actual speed at the bottom of the hill is measured, it is found to be only 50 metres per second, so it should be 70. Explain in detail why her actual speed is less than the one you've calculated in part 2. Now you can see there's 4 marks here, and only 3 lines to write 4 kind of statements. So the best way to tackle that is to think about where does the energy go. So the energy is lost as heat and sound, so that's the energy change. You could say energy is changed to other forms, but I think you need to be a bit more specific. This is due to friction, and where is the friction acting? It's between the skis and the snow. Okay, and that means that there's less energy available as kinetic energy at the bottom. So skier moves more slowly. Now you'll have more room and a thinner pen than me, so you'll be able to hopefully write that in a bit better. So there's 1 mark for saying where the energy is lost, 1 mark for saying friction, 1 mark for saying there's less energy available as kinetic, and therefore that the velocity is reduced. So there's where you get your 4 marks. That's the kind of question there that's maybe difficult to see how do you get 4 marks out of it. But if you can try and describe in detail why the speed is less. So the question you're answering is, why is the speed less? And so explain that the speed has been reduced there. At the bottom of the hill, the skier slows down from a speed of 50 and stops in a distance of 20. Calculate the average braking force needed to stop her in this distance. Remember, her mass is 60 kilograms. So this is a very, very similar question to the last question, where you are going to be using work as force by distance. So the work done that has to stop her, she's now moving at 50 when she gets to the bottom. So she's this 20 metres to actually get stopped. And what stops her? It's the friction between the snow and the skis. And so that's work as force by distance that we're going to use there. So the initial energy that was available was the kinetic energy, was equal to half mv squared. And that's going to be converted to the work done by the friction of the snow. So W equals a half, and we're going to multiply M, which is her mass. Where was it now? Her mass was 60, times her velocity, which is 50 squared. So the work done there is 75,000 joules. And that's coming from the work done that the snow has to do in stopping her is equal to the kinetic energy she has at the bottom. So work is force by distance. So we're saying 75,000 is equal to force by distance. We're looking for this force. We know that the distance is 20 metres it takes her to stop. And so F is equal to 75,000 divided by 20, and the answer is 3,750. So there's 5 marks there. There's 1 mark for saying this, 2 marks for 1 mark for this, 1 mark for this. There's a mark for saying that is equal to force by distance, and then a mark for your final answer. So that's a fairly stiff question there too, and it's worthwhile maybe going over that a couple of times till you're sure what you're doing there.